Hello, my name is Miles Schofield, and welcome to Uptime with AOPEN, a short format webinar series where we cover topics that are of interest to the IoT and hardware industry. And of course, on the first one, we're covering the hot topic of this year, which is chip shortage. There's just been massive amounts of media coverage, a lot of it wrong. So I figured this would be a great opportunity to talk to you about what's really going on from my perspective and what's affecting the chip shortage and when it'll get better and what we've been doing about it here at AOPEN. So let's get started. So the two primary topics, which sometimes can be conflated when talking about chip shortage, is of course the first one, which is IC availability, which is what caused standard components to go from 8-week lead time to 55-week lead time. And the second, of course, is what's going on with Intel, right? Processors in general, high-end, low-end processors, which is a separate sort of issue. Has to do, of course, with some of the changes that happened in 2020, but we'll get more into that about what's going on now, then, and in the future a little bit later. So let's get started. This is going to be a very high-level a webinar, so it's just to keep you informed about market forces and how manufacturers play into these different sort of issues. So the first thing, of course, is to talk about that there's just been a massive amount of chip shortage coverage in this year in particular. We knew about this at AOPEN, of course, about halfway through last year, maybe a little bit earlier, because you could tell just from the extreme market change due to all the regulations surrounding 2020 that there was going to be a lot of logistics challenges. Of course, you can see that the news sort of picked it up around December, and it's just been getting, I feel like every week you just see more and more of these things sort of speculating about what happened, what's going to happen, and things like that. So this webinar, of course, aims to clarify that. So to get us started, so you're a little bit more familiar with the topic and why it has affected so many things, is that the bottom line is that everything has integrated circuits in it. Absolutely everything. Your computer's power supply, anything with the screen on it, or a controller like a heater or a air purifier or a car, absolutely everything has little microchips or ICs in it, which means that if there's a shortage or there's logistical challenges or anything like that for standard components, you're going to have to wait. Right? There's going to be competition over them, and so there's going to be a squeeze. So that's the reason why pretty much every single market segment has written an article about how this sort of shortage has affected them, because it almost affects every market. So to clarify exactly what is an integrated circuit, for those of you who don't know, it's basically just a way to make typical electric circuits very, very small. The main one that you may know about is, of course, making transistors very small for processors, which are a type of IC. So to do this, you just take, instead of making the components individually, you just print them on a very, very small piece of silicon, and that silicon goes inside that typical black box you see on the right-hand side. And you can see it's compared to the black box, the little piece of the integrated circuit itself is just extremely tiny, right? So this can be all sorts of different components, and of course, microprocessor is a type of IC as well. And as I mentioned, these things, if you pull open any piece of electronics, they'll have these little microchips and integrated circuits as part of them. So that's why they're so prevalent in basically everything we buy today. So the main problem with a lot of the ways that the news covered this particular is that they looked at the manufacturing of ICs as sort of a fixed, basically a fixed output, right? So the issue with that is, if you really did just have a fixed output and manufacturers didn't sell anything in 2020, then they should just have a huge pent-up reserve of them coming into 2021, and there should be no shortages. But it's not, it didn't work like that. What happened was that the market shifted, and then the fixed output was bought up by obviously the shifted market, so that when the market's trying to shift back, it obviously hit a whole bunch of snags due to competition. And that was the primary catalyst, and I'll talk about exactly why that happened. So the primary three things that happened when that affected the market is, of course, the first thing you have to understand is that manufacturing sites have classes. So some ICs are more complicated to manufacture than others. Of course, storage is easier to print than logic and processors, and it's not viable to print storage using a high-end process. Best way to think about this is basically storage, RAM, and SSDs are types of ICs, if you didn't know, and they're much cheaper to manufacture than processors. So if you can't basically say, if we're looking at a fixed output system, that a shortage in processors necessarily has to do with a shortage in storage, or has anything to do with storage and storage or RAM prices, right? The best way to think about this is just having two separate classes or multiple classes, and the reason why it doesn't work if you're short on storage and you say, hey, why don't we just make more storage? Let's use our processor line to do that. That's like going into Lamborghini and saying, hey, we need some more Ford Focuses. Why don't you just make a few of those? It's not possible. It makes zero business sense, and you're going to waste a ton of money. So you sort of have to understand that manufacturing sites are designed to make certain classes of ICs, and that's where your fixed output comes from. The second, of course, is manufacturing priority. So as the market shifts, IC companies will prioritize producing higher end products with more margin. Makes sense, right? If you have the choice to make a 1 cent or a half a cent component versus making RAM, which is under a huge squeeze and worth more money, you're going to make the RAM, right? And obviously, if cuts are made, they're going to be to those lower margin business. So as long as there's a squeeze on a certain class of manufacturing, then the price is going to go up, and there's going to be a huge squeeze on those lower end components, which is exactly what you're seeing. You can buy RAM, the cost has gone up. However, the real lead time has come on those cheaper components, which no one wants to make anymore effectively. The last thing is, of course, IC manufacturing is scalable. So pretty much every article or person I see talking on this issue says that it takes forever to ramp up. That's true from a typical business sense, but that's not true from a money sense. Of course, you could ramp up an entire processing fab in the United States in a year. However, there's absolutely no business reason to do so. So just because, so you have to think about it's not impossible, it's just not feasible from a business standpoint. You wouldn't spin up additional fabs just to make low-end chips. It'd be an extremely difficult way to make money. And so the way that I'll talk a little bit about what Intel and the government is doing to try and fix this and subsidize this type of manufacturing so that we have a more strategic reserve of this type of manufacturing. All right, so let's talk about briefly what happened in 2020 and how that market actually shifted. So as we know, worker disruption, which caused manufacturing to slow in certain areas. Not only that, and a market shift towards, of course, home computing, all those sort of things. Everything from screens to home electronics to computers, laptops are absolutely huge. And so this sort of market shift into certain types of electronics created a severe backlog of those lower end stuff that no one really wants to make. Like individual power supply controllers, or the cheap chips that go into a Tesla and things like that. So you can see that manufacturers are able to charge a premium on profitable component types until the market returns to normal, which of course you can see on the right hand side here. The price of RAM and SSDs is just going up because there's still major market pressure to provide that type of product as people sort of debate returning to the workforce. And of course, the second one is, of course, manufacturers which use low-end components have to fight over the fixed production or limited production of those low-margin chips. And so what do manufacturers do? Of course, they buy out the manufacturers. So you can see the article in the bottom right, TSMC basically took a bribe from Apple and agreed to make their chips first over what would probably be more profitable business for them. So to cover what the government's doing, this news article came out a few weeks ago, and basically the U.S. government is just trying to subsidize this type of manufacturing stateside. Obviously, in the United States, we know that you only really want to make the the highest margin stuff here, but it did take initiative to try and support lower end IC manufacturing in the United States. And as a coincidental, as Intel says, a response to that, they said that they're spending $20 billion to build 2 new chip plants in Arizona, and I'll talk a little bit more about that during the Intel section. So finally, for this section, let's cover what AOPEN is doing. So at AOPEN, we're part of Acer, which is extremely important to us in the last year and a half while the market has been facing all these challenges. So since we're part of Acer, and Acer is number one in a number of segments, we're able to leverage their ability to acquire key components at huge quantities, which allows us to make our products which we normally wouldn't be able to make. So huge thanks to Acer and their support team for the past year and a half for sure. So let's talk about Intel a bit. So Intel has been speculated on for the last few years, and ever since BK or Brian Kurzanich left, and they finally have Pat reinstated as of February 15th. And he comes in and he says, you know, we're back. Intel's back. The old Intel is now the new Intel. They missed some revenue targets. So this sort of news and their coverage of Pat being announced as the new CEO was very interesting because normally you wouldn't sort of say there was anything wrong, right? They did miss revenue targets, but their sort of direction is sort of you know, that we did quote unquote something wrong, or there was where you have catch up to do, or all these things, which I thought was pretty interesting. But what it came down to in terms of Intel's mistake is that they were just unable to meet the expected demand from the market growth, and which caused them to miss revenue goals due to basically execution weakness on a few process nodes. What does that mean? So it basically means that obviously a huge amount of lower end processors were in demand in 2020, but aside from that, they probably would have had manufacturing challenges anyway, and they weren't able to keep up with the demand, not only from the market, but in other areas too for those types of processors, right? So that's basically what happened with Intel, is that they weren't able to manufacture certain classes of chips as much as they would have liked, and that's what Pat Gelsinger's design is looking to do, in addition to his primary goal, which is trying to develop their foundry business and compete with TSMC. When we talk about Intel's competition in the processor space in particular, not on the foundry space, you always have to talk about AMD. First thing to always remember is that Intel owns a lot of AMD. And the second thing is that Intel's bread and butter in this space is that gray line at the bottom. It's really about server for them. And so when you talk about business lost by Intel during 2020 or in the past year, I mean, as the last chart just showed, I mean, their revenue is still going up, up, up. It's just not developing as much as they want in these other segments. So the primary, how I view Intel and their core processor production and design is really that gray line. They want to dominate that server market as much as possible. And who's their primary? The risk here is, of course, that these other segments, desktop, mobile especially, and this word over here, overall x86. So one of the key things that a lot of people are talking about is, of course, what happens if all of desktop and mobile move to ARM, right? Microsoft may release a full version on ARM. They are already supporting Windows. Chrome has a full version on the M1 chip. So what happens if basically the market segment for mobile and desktop basically 100% turns to ARM? And that's Intel's real challenge when approaching the market, is that they may hang on to server, but if they only have server and absolutely every single other area goes away, then then we're looking at foundry. So that's exactly what Pat Gelsinger said. So let's talk about foundry and what it is. So foundry is just basically you don't design products, you just make them. You're basically just a manufacturer. It's sort of the best way to think of it as being sort of a white label. And lots of people use foundries. I mean, NVIDIA doesn't manufacture any of their chips. They're a design company, and they use foundries to make basically every chip that they design. And so that's the new direction that Intel's been going in, particularly from a lot of the forces that happened in 2020. Um, they've obviously had a foundry business that's been around for 10 years, I think at least 10 years. But this is the first time where they're really doubling down and really trying to announce that this is their strategy. As you can see at the bottom, full stop, period. It does not depend on a penny of government support. Doubtful, right? Like I said, it was pretty coincidental that the government announced so much stateside support for this type of manufacturing, and then Intel says we actually don't need any government support, right? And Gelsinger said on Tuesday, believe foundry market could be worth 100 billion in 2025. But of course, when we talk about Intel, they are not even on the map. You can see that, yeah, they don't even have a logo on the Global Foundry Services wheel. They're part of that 8%. So this is a massive, massive challenge for Intel going forward to see can they acquire key customers? Can they develop technology to compete with TSMC, et cetera, et cetera? That I don't know is going to happen. So we're definitely going to have to see on whether Pat Gelsinger's foundry plan will be successful. So finally, to wrap things up, let's talk about what AOPEN's been doing due to its partnership with Acer is that we do have plenty of units available. So across the board, you should know that AOPEN sells Windows, Linux, Chrome, Android devices. We even have some of our wide temp devices in stock and some of our specialty small conference room cameras and classroom cameras as well. So feel free to reach out to us, anyone on our sales team, info@AOPEN. We'll tell you exactly what's in stock, how, if it's not in stock, how long it takes to get made, and all that sort of good information to keep you on track and your customers on track as well. So finally, wrap it up for this video. Basically, a shift in market demand during 2020 and worker disruption put power in the hands of low-end IC manufacturing. So when is this thing going to end? Basically, once the market shift sort of neutralized, as we saw, I don't anticipate any new production going online immediately. So if a ton of workers move and decide to keep working from home and updating their systems and a whole bunch of desktops and laptops are sold, then this trend in the high hard drive and RAM price and processor price may continue for at least another half year, another year at least. So until the market comes back to normal, we may get this squeeze just because it's a manufacturer's market effectively. Second is that the government and Intel are both promoting a new stateside production to try and alleviate some of these issues in the future if they happen to happen again. But they are long term, so it's not going to do anything short term. And as I mentioned, even though you can build a fab extremely quickly, they're not going to, and it's still going to take years and years to ramp up. And finally, AOPEN has leveraged Acer to meet our customers' demands in the past year and a half. They've been very helpful, and always check with us on our availability and products which we have directly available in channel. So that about wraps it up. Thank you for joining. I hope you enjoyed this episode of Uptime with AOPEN. And of course, if you have any questions about what I should cover, if you want to hear more about Intel or graphics or new IoT technology or that sort of stuff, please give us your feedback as well too. Thanks so much.